back. Not everything is put in Infinite Campus yet, but it will be ASAP. Okay, I have just been madly trying to get things graded and grading things and then putting them in Infinite Campus. Like, to me, the grading is more important, so that's what I've been trying to do. I do want to give you a friendly reminder that if anything is still in your hands that you wanted to turn in for late credit, all of that is due by Friday. No ifs, ands, or buts, okay? No, oh, I meant to do it Thursday night and then my dog lost his tooth. Like, I don't care, okay? It doesn't, I was trying to think of something kind of ridiculous. It needs to be in my bucket by Friday. Got it? I'm gonna leave it 3. It needs to be in my bucket before 3, okay? I did get all of your, thank you, all of your full lab write-ups graded if I had one. So if you look on Infinite Campus and there's no score in there, I didn't get them written down, then I don't have one from you. So that would need to come into me by Friday if you want partial credit for it. And I had some notes to give you. I feel a little bit bad because it took me, I don't know, 5 years or something like that to get your labs graded. But the positive spin that I'm going to put on it is you have another lab due on, when is it due? Friday. And so now by getting this feedback now, it's going to be on the top of your head so that when you're writing this next lab, you have that. So you may want to take some notes over the things that we're going to go over. So you don't have the lab in front of you. I did grade them all, and I write on them when I grade them on my computer. And in the comments section on Infinite Campus, put the URL for where it's available on Dropbox. Does that make sense? So you should be able to get access to it that way. If for some reason you're having a hard time with that, send me an email and I will get it to you via email. Does that make sense? Okay, but I haven't heard back from anybody yet that it doesn't work. So until that, I'm going to assume that it does work. So like I said, everybody has their lab in Infinite Campus if I was able to grade it. But this is just kind of some general comments. As I go through this, you may want to pull out the lab rubric. And if you don't have a copy of it, I put my little pile of them out. They're actually next to Michelle here. If you would like to grab one so you can remember what things are required, okay? I'm just going to go kind of step by step through some lab feedback. I will tell you that as I go through this, it often feels kind of dry, right? Like, oh, blah, blah. But these things are important. Since I'm telling you them now, and I was fairly generous when I graded that first lab, I'll probably be less generous with these things on the lab that I grade over winter break. Does that make sense? I mean, it's just kind of logical, right? So just to kind of keep that in mind. All right, here we go. So the first section was the design section. So thinking about some of the things that I saw on the design section, okay, aspect 1 says for you to define the problem and select variables. You can be really, really explicit about this. My research question was, how does blank affect blank? That is totally valid, and in fact, I would encourage you to do that because then it's defining it really, really clearly. So something like, how does blank affect blank? Okay? One of the reasons I like this is because then right here in those 2 blanks, you've identified your variables, your independent and dependent variables, right? They are right there. And then you can write another sentence that says, in this experiment, my independent variable was da-da-da, and this is how I changed it. My dependent variable was da-da-da, and this is how I changed it. Okay? Does that make sense? So it can be really explicit. You don't have to write cryptic prose that describe these things that, you know, are like poetic. I mean, I'm not trying to knock poetry, but this doesn't need to be poetic, okay? If you really want it to be great, but you have to make sure everything's there. And I'll tell you, it's harder for me to find it if it's all fancy pants. Which of these is the dependent variable? Which one's the independent in these little blanks here? What's that? What's this one?
Independent.
That's one of them.
That's the independent.
Independent? So like if we think about the acceleration to gravity lab that many of you wrote up, not everybody, but that's okay, and it's totally fine, you had the choice, right? So how does the height affect the drop time, right? Does that make sense? So this one is going to be the independent variable. And just want to remind you so that you know what these things are. So the independent one is the one that you pick, right? You set it and you varied it, but you picked what the values were. And then this one is the dependent, okay? And that's the one that you're measuring and trying to figure out what the relationship is. What is a control variable?
One that you keep constant throughout the lab.
Right, something that you keep constant, that you have control over, and that you decide to keep constant, okay? So sometimes people go on this big long list, like listing all of these things, and I'm controlling for the fact that I'm staying on the earth, and I'm controlling for the, like all the, like, I just need to know the things that you're controlling that you could have changed. Like, for example, if you're dropping things, you could have given it some initial velocity downward. And if you did, then that would change the values. Does that make sense? Okay, so those are the things that you want to talk about when you're saying, when you've got your control variables. And that's the second aspect, right? Designs a method for controlling variables. So the things you don't want to change need to intentionally be not changed. Aspect 3 says, develops a method that allows for collection of sufficient relevant data. Most of you did a very nice job explaining to me what your lab did. Some of you kind of assumed that I was standing right next to you, and so you didn't tell me what your lab was about. So make sure you kind of walk me through it. I don't need like, you know, a 5-page monologue of what happened, okay? But just, you know, explain to me what the procedure was. But the key here, the thing that I didn't see as much as I was hoping for, was some sort of justification. Justify to me that you have enough data, that you're collecting enough data. Okay? We did 3 trials of each at 3 heights. Okay, that's a statement. That doesn't justify for me why that's good, why that's enough, okay? Sometimes, and I think you do this, but you don't maybe consciously do it, you know, like if you take some data and you get one value that's totally different from the other 3, you might be like, ooh, that's a bad data point. I need to do another one, you know what I'm saying? That's the kind of thing that I want to see here. So, you know, our design said that we were going to take 5 data points. After taking the data, we saw that all of our values were about the same, so we felt like that was enough. That, like, you don't need to say it exactly like that. I don't need to see, you know, 50 labs that are exactly the same, but something like that to justify to me that you've taken enough data and not just because the teacher told you. In fact, I didn't tell you, right? But, or my teachers have always said, you know what I mean? Okay, that's what I'm looking for. The other thing, so number of trials is one thing to talk about. The other thing is the number of, I'm going to say values for the independent variable. Now, I'm not expecting that you go back through and do your lab again if you didn't do this, but just kind of for future reference, if you only do 2 values for the independent variable, and you graph that, you're going to get 2 dots, one of which might be totally wrong, and so that doesn't really help you very much, you know what I'm saying? So like if I graph and I've got 2 dots, well, I can't really figure out much of a trend there. Might be a line, but it might be that this one was totally wrong. So that would be sad. If you have 3 dots, which I think is what many of you all do or have done, then I don't know if that's a curve or if it's a straight line and one of those is just an outlier. You know what I'm saying? How can I know with more certainty? More dots equals more certainty, right? So maybe doing like 5 different values of independent or something like that. The more dots that you have, the more you can learn, because maybe actually what it looks like is that. And this one that we assumed was perfect is actually the not so perfect one, right? So it's just, you know, one of those kind of food for thought things. Questions on the design section of the lab? Make sure I didn't miss anything. Yeah.
Can you repeat what you said for like justifying the method of trial?
Yeah, so I would say something like, you know, we plan to do 5 repetitions at each, you know, setup or whatever. And after taking the data, we looked at our values and they were all, you know, about the same. Because you want to, the reason you take lots of trials is to ensure precision, right? To ensure that you don't have random error. So that's the kind of thing you want to say. Does that make sense?
Yeah.
And then this one you're using to help ensure accuracy. Other questions for this section? Okay, let's take a look at the second one. So the second part was data collection and processing. And I should have said this earlier, but I'm going to let you know right now. So when you open up your document, assuming that everything worked, and I think it should, at the top right-hand corner, you'll see this. And it should look kind of like when we did this, I don't know, like the very first day of school or something like that. This is design, and there are going to be 3 numbers. Data collection and processing will be 3 numbers. Conclusion evaluation will be 3 numbers, and those go with each of these aspects. So it's kind of like this little chart, just in really small form. Okay. So what I do when I'm scoring it, I just want to make sure that you know this, is that I add those up. Then that's 9 times 2, which is 18. And then I give you 10 points for a good job. You're making good progress. You did the lab. So it's a total of 28 points for the lab. So that's where the value comes from. Okay. I do reserve the right to take away a couple of those points from the 10 if your lab is unreadable or there's lots and lots and lots of like error, like proofread errors, right? Because there's nothing in here about proofreading. I'm not going to get really cranky if it's not exactly perfect, but you should proofread it. Okay, there were a couple that were like, oh man, like, oh yeah, proofread is good. Okay. Data collection and processing. The recording raw data, most of you did just fine with that. Just one little note, and again, this is more of an aesthetic thing than something that I would, you know, grade off for, but just an idea to include borders on your table. It just makes a whole lot easier to read it. Do you know what I'm saying? As opposed to just like this pile of numbers, and it's just kind of hard to see what's what, especially if the numbers are right justifying and the words are left justifying. It's kind of hard to see it. So if you just, when you're on your table and you right click, one of the options is to include borders. Okay, do you understand what I'm saying? Does that make sense? Like the actual black lines. And I mean, you could, if you really wanted to, spend lots and lots of time shading it and all of that, and I don't need that, but if it makes you happy, that's fine too. But just having some lines just makes it easier to read. Okay, and to clarify, you need to have your raw data in your lab. Okay, when you turn your lab in, it should be one document. One document, either a Word document or a PDF. That's all I can open. Okay, Word document or PDF. So save that for me. One document so that I can see everything right there. Okay. I think everybody was fine on it, but just, you know, on the raw data, making sure you have units. That should go without saying at this point, but just in case. The next part is the processing. This part, for some of you, went really well, and for some of you, was a little rough. Okay? So remember that in all of these labs that we do, we're trying to be a little bit intelligent and not just ask like a genuinely not ignorant, that's not what I'm saying, naive question of how does blank affect blank? Like, no, we know. We have kind of a sense in our gut and or because of theoretical physics that we know that if you graph displacement over time, will that give you a straight line?
For dropping an object?
If I'm dropping an object.
No. Then no.
That won't give me a straight line, right? I know that. You know that too because we've been talking about that forever, right? So we know that in order to linearize the graph, what do you need to do? Do you remember? It's been a long time since we've done this, but think it through. What did you have to do to make it a straight line? Oh, man. This would be a good thing to know January 12th or whenever it is that we're taking our final, right? We want to make sure you know this stuff. This is important stuff.
Is it the square root of the displacement? Or is it 1 over displacement?
Maybe we're not quite understanding the question. So I drop something, right? Like a puppy or a ball or a something, and I time it, and I want to know the relationship between the height and the time, right? That was the question that many of you asked. But I know that if I graph this, I'm not going to get a straight line. What am I going to get here? Parabola, right? A curve, yeah. So I also know this, don't I? I want to get something. So these are not correct. Let me make that really clear. What am I going to graph on the x and y axis so that I get a straight line? That means we want to get it something like y equals mx plus b, right? So talk to your neighbors now that you're, right? That was the goal. The initial velocity is supposed to be 0. So I want to get this thing to look like this thing. Do they look alike yet? Not exactly. How can I make them look alike? Or what can I graph to make them look alike?
You can call t squared x.
If I call that one thing, right, that's my x value. 1/2 a is my slope, and this is my y. So, is that okay so far? So one of the skills that I'm trying to help you acquire this year is the idea of linearizing a graph. Okay, we're practicing that. I would like to see some more practice of that on the next lab that you turn into me. And not only do I want to see that, I also want to see where your reasoning comes from. That is the processing the raw data. Because you're not actually going to put y and t here, right? You need to do t squared. But not only do you need to show me that you can square stuff, because I hope that you can square stuff, because you've been squaring stuff since you were in 3rd grade, right? Or so. I also want to know why you did it. That's the processing. A paragraph or so to explain to me why it makes sense to put y versus t squared. Okay? Not just divine intervention told me, right? Like something came to me and said, use t squared. No. Wrong answer. Wrong answer, okay? Is that okay? One other little hint for you is that if you want, and again, this is kind of like the table borders thing. I'm not going to take points off for it, but it just makes your final product look better. Do you guys know about equation editor in Word? So let me show you it real quick. Let me see if I can make myself, oops, let's go back. Sorry. I just want a new thing. New document, please. So again, not something you have to do, but something you are welcome to do. So every version of Word is a little different, right? But if you go to Insert, wherever your insert is, and I think you can also right-click Insert sometimes. But anyway, if you go to Insert and then say Equation, then you get this really lovely wealth of skill, okay? You can put in all kinds of awesome things, like fractions with square roots. And I mean, like, you can do all kinds of awesome stuff. You can, and then you can put in, like, I don't know, crazy letters and symbols and all kinds of things. And then when you do it, and it's really hard to see right here, but it looks just like it would in like a textbook. It's just kind of pretty, Again, not something you have to do.
How did you get to that?
You go to Insert, Equation. Insert, Equation. And then it's pretty self-explanatory. You kind of poke around in it. Sometimes it takes a little time to practice with it, but it's not a huge time suck. I think it's kind of cool. Yeah. And I don't know, it makes things look a whole lot prettier than typing out like D equals VIT plus 1/2 AT caret 2, right? Like, that's ugly. I understand what it means, but this is a whole lot prettier. You know what I'm saying? So that's just one of those, an opportunity. Okay, so that's processing raw data. Presenting the processed data appropriately. So that means a graph, okay? That means a graph with a title probably, and some labels with some units. These are basic things that, again, you should know. And if you've linearized your graph, Part of the reason you want to linearize it is so you can get nice stuff, and the other reason is so that you can actually learn something from it. Right? So we linearize this graph, so that means we can get the best fit line. Bless you. You can get the best fit line, so it's like y equals, I don't know, maybe 2.7x plus 3, let's say. I'm just like picking random numbers. Once you have that, in the next section in conclusion evaluation, use it. This tells you stuff. So much stuff. So much stuff. What does the 2.7 represent? That's the slope of the graph, and because we're clever, we know what the slope should be, right? So you can then, in your conclusion, comment on that. Okay? One thing I noticed, especially in this class when I was grading the labs, is that a lot of you wrote conclusions based on the theoretical physics. Of course there's a relationship between the displacement and the time. Because of this equation, I know it's true. Like, yay team, you didn't actually have to do a lab to like look at an equation, right? I want you to write about this. Experimentally, I found that there was a relationship. A direct relationship between y and t squared. Okay? If you're going to say that two things are proportional, that means that as one goes up, the other goes up by the same proportion. Okay? So y is not proportional to t. That's not true. Y is proportional to t squared. That means that y equals some constant times t squared. Okay? This looks like a whole lot like y equals mx plus b with no b. Do you see what I mean? That's what we're talking about. That's what directly proportional means. Is this okay? I know I'm throwing a lot of stuff at you, but I just want to make sure you have it. I am recording this, so as you're working on your stuff, you can come back and listen to it again if you need to. You're very welcome to. So in your conclusion evaluation, let's just go there. In the conclusion evaluation section, the first aspect says, states a conclusion. This little prepositional phrase is a really important one. With justification. Based on a reasonable interpretation of the data. So when you have a conclusion, use data to back it up. Okay? And don't stop there. Use that to take another step. And if you, let me back up. What should this have been if it was a perfect world?
Like 4.9 something.
Like 4.9. Where did he get that number? Wow. Divine intervention, right? No, probably not. Where did this number come from?
1/2 fixation.
1/2 of 9.8, right? Half 9.8 is 4.9, so that's what it should be. But did anybody get that? No. So then you get to talk about why not. That gives you the space to talk about the weaknesses. Okay? The weaknesses of your lab, I need to be really clear here, should not be things that you messed up. They should be things that either you did not account for or that you could not control. Okay? Human error is not okay at all. Either you need to be a little more specific. Okay? Is there a reaction time involved? Sure. Okay? Often, though, the reaction time that we get doesn't skew it in the way that we think it should. So you need to really think about what's going on there. So you can talk about reaction time, but don't just say human reaction time. Say a little more. Think about how it may have affected it. You can talk about air resistance, but say a little more. This is how I think it affected the data. Do you know what I'm saying? That's what we're talking about for weaknesses. Yeah.
What do you mean it doesn't scoot in the way you think it should? Human error.
Often the value for acceleration, so if you drop a puppy, then you're going to get an acceleration that's much smaller, right? Sometimes when you drop like a ball, you'll actually get an acceleration that's higher, which means that it's not that they were slow on the uptake, but they were actually too fast. They were anticipating things. And I often have people that have a higher acceleration due to gravity, so it was higher than the 4.9, and then they're like, oh, the reaction time messed it up. Well, yeah, but you didn't tell me how. Does that make sense?
Mm-hmm.
Yeah. So it's just that thinking things through. Okay, so that's weaknesses. And then realistic improvements. You do not need to mechanize things to make it better. Okay? You don't have to hire a robot to drop your doggy in order to get better data. You can be specific. There are things, I know this might blow your mind because you guys are fabulous and wonderful and nearly perfect. Okay? Almost Mary Poppins-esque. Okay? Jack's like, yeah, I know. Yeah. Okay? There are things that you could have done better. Or things that you could take a step further to get to do the lab in a better way. That's what I want to know. Given the equipment that you had, what could you have done better? Realistic improvements, okay? So you could say something like doing video analysis, because that is something that's within your realm, right? We could do that. But talking about like buying a vacuum chamber and timing gates and like that's not something that's within our budget. Would it make it better? Yes. Those would be improvements, but I would say probably not realistic improvements. Does that distinction make sense? That's what I'm talking about. Okay. What else do I need to say? I'm just making sure I look here. I didn't miss anything. Very last thing. And this is a super little one, but it'll make my life easier. When you save your lab, so I already put things on Infinite Campus for you to save your Excel spreadsheet for the lab that you are not writing up in full. Right? We have 2 labs that you did last week. The spring lab and the pendulum lab. Okay? One of them will be a full write-up. One of them will just be a data analysis. So there's one column for the Excel. I think it says data analysis. Then the other one says full lab write-up. Please, when you save them with your last name somewhere in the file name. Okay? So you can write Addison Williamson is awesome. That's fine. Or you can say, you can just leave it however. But please leave your last name in there. Then I can find it easily. Then I don't have to go back through and save every one over again, which is annoying.
And you want those 2 just separate files?
Yeah, there are 2 different things on Infinite Campus. So there's one that has the full lab write-up. I think it says simple harmonic motion lab full write-up or something like that.
Right.
And there's one that says simple harmonic motion lab data analysis. So you pick which one goes where. Is that okay? That was a lot of stuff. Thanks for playing. All right. I'm going to take a deep breath. Why don't you put that stuff away. If you borrowed one of these, if you go put it back, that would be great. And then we will regroup with notes out so we can do some stuff.